confidence interval for the difference of two proportions. The assumptions that we need to be satisfied for a two-sample proportion are slightly different from those for a one-sample. Both of our samples must be independent, simple random samples from the populations of interest. The population sizes are both at least 10 times the sizes of the samples. The number of successes and failures in both samples must all be greater than or equal to 10. To make the comparison, we'll need to find the difference of our two proportions. So the sample proportion from sample 1 minus the sample proportion from sample 2. The standard error for the difference is found by the following formula. The square root of p hat 1 times 1 minus p hat 1 divided by n1 plus p hat 2 times 1 minus p hat 2 divided by n2. So this makes our formula the difference in our sample proportions plus or minus our critical value z star based on our level of confidence times the standard error. Let's do an example. The National Research Council of the Philippines reported that 210 of 361 members in biology are women, but only 34 of 86 members in mathematics are women. Establish a 96% confidence interval to estimate the difference in proportions of women in biology and mathematics in the Philippines, and then interpret your results. First, we need to identify which sample is which. Let's make the women in biology sample 1 and the women in mathematics sample 2. This makes our proportion for sample 1 equal to 210 out of 361, and our proportion for sample 2 will be 34 out of 86. Now let's check our conditions. We would assume that each would be a random sample from each of the individual populations. We'll also assume that these are independent populations, biology and math. And then we need to show that our number of successes and our number of failures are each greater than 10. Well, we have 210 successes and 361 minus 210 failures for biology, each are greater than 10. 34 successes for mathematics and 86 minus 34 failures for mathematics, so both are greater than or equal to 10. Now let's get our confidence interval z star, our critical value. So for a 96% confidence interval, our critical value will equal the inverse norm or Q norm, if we're using RStudio, of 0.96 plus 1 minus 0.96 divided by 2. So this would be our inverse norm or Q norm of 0.98. This value comes out to give us a critical value of 2.054. Next, we need our standard error. That's going to be the square root of 210 out of 361 times 1 minus 210 out of 361 all over 361 plus 34 out of 86 times 1 minus 34 out of 86 divided by 86. This gives us 0.0588. So our margin of error is 2.054 times 0.0588, which is 0.1208. So our confidence interval will be the difference in our proportions, p hat 1 minus p hat 2 plus or minus this margin of error. This gives us a confidence interval from 0.0656 to 0.3072. Interpreting this confidence interval, we would say that we are 96% confident that the true difference in proportion of women in biology and women in math is between 6.56% and 30.72%.